one last group and one subgroup to look at, and then we are done with annelids. Yeah, I don't know. Is that kind of sad? Maybe it is. Annelids are pretty weird and pretty wild. Yeah. So the last big group that we want to talk about are the mysostomids. Mysostomids. And they are a super primitive branch of annelids, we think, based on their genetics. And here are some mysostomids. Now, the super neat thing is that nearly all mysostomids that have been found live exclusively as parasites and only on crinoids. Now, crinoids are a kind of echinoderm, so a relative of a starfish. And these things will live on the arms. The arms kind of look like little feathers, so there's one right there, and there's one right up here. And you can see they're even spotted, so that they sort of blend in a little bit better with the spotted arms of the crinoids. So that's pretty cool. Let's go on. Here we go. And so, all right, so what are these guys? So here's a little family tree of these guys. These are a lot of the new ones that they're describing in this paper, and so you can see a lot of diversity in structure. There's some that look a little bit more like a typical annelid, like this black and white one, or this one over here, the long brown one. And there are others that have these sort of fantastic appendages, which are going to be sensory and locomotory. So they'll use some of these to sense, food, and they'll use others to move around. And we've actually got video, which is really crazy, of a mysostomid. So here we go. So this is a mysostomid, and it's moving along. So this is the back of the worm you're looking at, and underneath it's got these little tentacles that stick out. And here we go. Here are the tentacles. And so again, it's just body segments, and these are just little inflated tufts. This is either the mouth or the anus down here. I am not sure with. I'm suspecting it may be the mouth. But they'll just be at opposite ends, like that. And so, yeah, that's how they move around and lead their little parasitic lifestyles, which are pretty cool. So, mysostomids, and one other branch of the annelids that are quite closely related to mysostomids are the sipunculids. And so these are the peanut worms, not penis worms, peanut worms. That looks nothing like a peanut to me, or probably to you if you're familiar with the concept of peanuts. I don't know. It seems like they maybe ran out of names on this one, and somebody just, threw up a three-pointer. You can see one of those on there. If you want to go to that YouTube, it will take you to the video. Actually, what the heck? Let's go there, and we can see one wriggling around here. Sorry, let's copy this. Boop. No. And let's copy it this way. There we go. I have a broken key on my keyboard, so I can't do things normally and quickly, which is a shame. All right, young peanut worm. There we are. Yeah. So does that look like a peanut to you? I doubt it. And so what this thing is doing, once again, is it is furiously trying to burrow into the sand because it does not like to be exposed, because it knows that it's delicious, and if it's out on the surface, somebody's going to come along and snap it up and eat it. And so it is trying to dig in here, and it just does not seem to be working particularly well. But anyway, that's what they look like. Yeah, kind of neat. And so you'd look at that and say, well, that's kind of like a regular annelid, right? These are things, another thing that used to be classified in its own group, and partly that's because, so once they're buried, they're going to stick out this thing, and it looks kind of like the lophophore on a brachiopod or a bryozoan, something like that. But looks can be deceiving. So the lophophores on those creatures, like bryozoa and brachiopods, actually are they're bendy, but they're solid. They cannot be inflated and deflated. Whereas these guys are entirely hydraulic. And so the peanut worm can retract the fluid from these, and they will just deflate, and it can boop, pull them inside, or it can pump water into these, and then bam, they will feed as if they were a lophophore. Yeah. So similar sort of appearance, but yeah, different origin. So fluid-filled coelom, that's sort of the liquidy middle layer, and a hydrostatic skeleton. So they maintain water pressure to maintain sort of the pressure on different parts of their body. And yeah, by squeezing that water that's inside them around, that's how they can change their shape. And so, yeah, there we go. Sapunculates, which are genetically really close, they're actually probably belong to the same group as these guys, the Mysostomids. So, there you have it. That is the end of our annelids. And so, our question once again is going to be to tell me in as much detail as you can find about some of these annelids. And like I've been telling some of my other classes this term, what I'd like you to do is go out and read a little bit. There are wonderful, even Wikipedia pages on each of these groups. Try and find me one or two facts beyond what I've given you and recount those back, and then that'll make a great answer. And the test question is going to be something like you're going to pick out, I think, your top 6 examples of annelids. And you're going to tell me about some of their adaptations which relate to mating and eating. And so we got all these cool ones. I mean, do you remember the spoon worm with the little tiny, the sort of sex change on demand? And the little tiny mini male in the little man house inside. Do you remember the bone-eating worm that farms bacteria and has a little harem of teeny tiny males around its collar? Do you remember the Pompeii worm with that fluffy coat of bacteria? Do you remember the ice worm? Ah, oh, so many worms. Yeah. So be prepared to give me some of this wormy goodness. And yeah, soak yourself in worms. Read up on these worms. Worms are pretty cool. So this has been Annelids. Hope you enjoyed it. And yeah, tell me how this went. I would like to hear from you.